Hello, everyone. Good morning, good afternoon, good evening, whatever time of day it is that you're watching this. Good day to you, and I hope you are safe and sane inside your houses. And yes, the work must go on. So that is why I'm here. My name is Eloise, and I will be giving you a 30-minute lecture on quantitative data analysis, specifically with software applications of MS Excel, because that is what everyone has in their PCs or laptops, whichever you may prefer. So yes, this session will supposedly help you write your chapter 4 and maybe a little bit of chapter 5 as we interpret the data that we will be computing later on this session. Okay, so you will be needing your handout because all of the information is in there, even the steps that you will have to do to compute using MS Excel. So at the end of the session or lecture, each participant is expected to be able to do the following. So we will explain the descriptive and inferential statistics. We will be installing your data statistics toolpak in your Excel. And we will be computing again quantitative, descriptive, and inferential statistics with the data sample provided. And as I mentioned earlier, we will be interpreting the results as well. So, okay. So supposedly you are done with your data collection. That is why we are here right now to analyze your data and then, of course, interpret and find conclusion. And then afterwards, after writing your chapter 4 and 5, you will be doing your defense, which I know everyone will do so well. And because you will do so well in the near future, you will also be publishing your thesis. Yes, we will do that. Okay. So let's brush up on the scales of measurements real quick. So we have 4 kinds. So first is the nominal scale, which is basically just categories. The most common categories are gender and socio-economic status, maybe the program or the degree of a student. So as long as there's categories, it's a nominal scale. So next is your ordinal scale, which is basically rankings. So first, second, third, fourth, fifth, and so on and so forth. Okay. Next is your interval scale, which has no absolute 0 point. So what do we mean when we say that it has no absolute 0 point? It basically means, like for example, um, if the number is negative 0 or positive, it will mean something. The most common example of this is temperature. So if you have a temperature of negative 15 degrees Celsius, it just means that it's super cold and you have to put your jacket on. So it still means something. And last, we have the ratio scale, which has an absolute 0 point. So if someone scored a 0 in an exam, it means that he has no score. So there is an absolute 0 point. The lowest score you can get is 0, and that's it. So next, we will be brushing up again on your descriptive statistics. This is very basic. Supposedly you have learned this, some of this, during high school, and a part of this in your college statistics if ever you had a course on it. Okay, so first is frequency distribution. So it is the listing of how many times a score occurs in your data set. So along with this, you have to put the percentage as well. What else? So this is presented in line graphs, bar graphs, histograms, frequency polygons, whatever you think is right for your thesis, and whatever your panel thinks is also right for you to present. Okay, so measures of central tendency. This is very basic. We all know this since we were little teenagers. Yes, so we have the mean, median, mode. And we have your measures of variation. So range, it's just the difference between the smallest and the largest value in your data set. When you say variance, it shows how a set of numbers are spread from the mean. So yeah, if you have a graph, it just shows the dots, like how scattered they are. And when you say standard deviation, it is how many points or how close are the numbers from your mean. So if this is your mean, like how close are the dots from this middle line over here? I hope we are clear so far. So for inferential statistics, we will be discussing the three most common inferential statistics that is being used in health professions education research. Okay, so we have your t-test, of course, which is I think everyone likes the most. Then of course we have your Pearson R correlation and your ANOVA. So for your t-test, here is a very helpful and it's a very helpful table on what kind of t-test is best to use depending on your research design. So if you need help with your statistics, just go to this table and it will tell you everything you need to know. So here we have the t-test for one sample mean, and we also have t-test for independent samples or uncorrelated ones. And then of course we have your t-test for dependent or correlated samples. Most common example would be having a pretest post-test. So that is, yes, a dependent sample. And we have your one-way or one-factor or single-factor ANOVA and your two-factor or your two-way ANOVA, which we will be discussing later on. So when you use ANOVA, it basically, let me rephrase that. So if you want to use ANOVA, you have to have multiple groups. So if you want to compare the needs of 3 or more groups, then ANOVA would be the right statistical treatment for you. Okay. Again, Pearson R correlation, as we all know, is used to determine the relationship between two variables, specifically an interval or a ratio scale. Okay, we have a golden rule for interpretation. So later on, when we start computing the sample data, you always have to remember this by heart. So if your p-value is less than your alpha 0.05 or 0.01, whichever you will be using in your research, you reject your null hypothesis. So for example, if your null hypothesis is there is no significant relationship or no significant correlation between A and B, if you reject that, it means that there is a significant relationship between A and B. So yes, we will also be exercising this as we go along the way and compute and interpret your sample data. All right. So now here we have the Excel sheet or the Excel file for the sample problem. So I hope you have this with you right now, so it's easier for the both of us to navigate and compute for the statistics. Okay. So the first thing we have to do is to install our data Toolpak in Excel. So what we have to do first is go to File. So at the upper left here, we have your menu bar, click File. Then at the bottom of this, there's an Options button, click that. Then this window will appear. Click on Add-ins and then press Go. Check Analysis Toolpak. Click OK. So that's it. It's as simple as that. So when you go to your data on your menu bar, you should have this little button right here. It will be the source of magic when you use your Excel. Okay. So here we have our first problem, our first sample problem we will be computing for descriptives and t-tests. So the problem is that a group of 30 patients are divided into two groups and randomly assigned to experimental group and a control group. The scores obtained by the two groups of students or patients of the same test are presented below. Test the hypothesis using a 0.05 level of significance. So we have a perfect score of 30 and a passing score of 15. So the null hypothesis is that there is no significant difference between the scores obtained by the experimental group and the control group. If you take a look at your table, the t-test table that I have provided earlier. So an experimental group and the control group are not correlated to each other at all. So for this specific example, we will be using t-test for independent samples. So let's write here, t-test for independent samples. Yes. Yes. So first, we will be looking for the descriptive. So what we will do is go to data over here at the top, click data analysis, look for descriptive statistics. It's as easy as that. This list here is in alphabetical order, so it's very easy to navigate. Click OK. Input range, so you have to do this one by one per construct or per variable, whatever it is that is required of you. So click labels in first row because you do have the labels in the first row. So when you click output range, what I like to do is put it in just one worksheet so it's easier to see and it's easier to interpret. So if you click output range, it will highlight again the input range, so be careful of that. So when you click output range, always click the blank space beside it. So once you click that, you choose whichever area you want your table to appear. So for cleanliness, for organized purposes, let's put it here beside this table. And then press Summary Statistics. and press OK. So we have the mean, the median mode, standard deviation, the count for your EG scores, and let's do the same for the control group. Data analysis, descriptive statistics. So let's change the input range, also change the output range. Summary statistics is clicked, and we press OK. So what are the common things that you have to look for here? So of course, you will be needing your mean and your standard deviation. So let's compute for t-test now. To compute for t-test, here on Excel, it doesn't tell you if you have equal or unequal variances. So because when you click here, you'll see that there is equal variances and unequal variances. So how would you know if your variance is equal or not? So we do another test for that. It's called F-test. So let's look for F-test. F-test to sample for variances. Click OK. Variable 1 range, I mean. Labels at the top, of course, you have your alpha 0.05, pi 0.05, and alpha range, let's put it beside here. Our descriptive statistics, and then press OK. So you have your F-test now, and the important values to look at here on this table is these two. Highlight that. So you have your p-value and your F critical. So the interpretation for this is that if your p-value, let's put it at the bottom, if your p-value is less than the F critical, it means that you have an equal variance. So our p-value is 0.02 and our F critical is 2.48. It means that our p-value is less than the F critical, so we will be using t-test for equal variances. Let's put it here. Equal variances. All right. So now that is sorted out, we can continue on and computing for our t-test. So click again data, go to data analysis, look for t-test to sample assuming equal variances, press OK. So put on the variables that you will be comparing. Hypothesize mean difference is always 0. Remember that it's always 0. Labels at the top, alpha 0.05. Output range, be careful of this one again. Be mindful of that. Output range, let's put it here. So we press OK. So now we have our t-test. So you can also see that it also provides you with the mean score and the variance and whatever, but this is more informative since you already have your standard deviation here. I am so sorry for my dog. He's just getting excited. That's why he's barking out loud. Okay. So If you look at your table here, you have your p-value for one tail or two tails. So for example, we will be using two tail for this specific problem. So let's highlight it. So let's highlight your t-stat because it's also important. And your p-value two tail. Let's put it here for so we can see it easier. 0.07. So again, the golden rule for interpretation is if your p-value is less than 0.05, you reject your null hypothesis. If we see this, our p-value is actually higher or greater than 0.05. So if that is the case, it means that we will accept our null hypothesis. If we accept our null hypothesis, then it is true that there is no significant difference between the scores obtained by the experimental group and the control group. So it is your job to look at your RRL for possible explanations why you have this result. Okay, so now we have our test. Congratulations, you have computed for your very first inferential statistics. Yes. So always remember to save your work, save your work, save your work. So what I do is I press save a couple of times before I move on to the next task to be sure. You know, we're extra cautious about it. So our next example is looking for the Pearson R. So our problem is that a researcher investigated the possible relationship of 20 faculty members' calorie intake and stress levels in one day. So again, we are looking for the correlation between calorie intake and stress levels. So the calorie intake and stress levels are presented below. Compute for the Pearson R correlation. So when we say Pearson R correlation, we have a positive relationship, which is +1, 0, which means no correlation, and -1, which means you have a negative correlation. So our null hypothesis is that there is no correlation between calorie intake and stress levels of faculty members. So first, what we have to do is, of course, look for the descriptive statistics. So let's press data on menu bar, click data analysis, click descriptive statistics, and highlight that again. Where should we put it? Let's put it here. Press OK. And then do the same for the other variable. Wow, my dogs are really excited right now. Yes, so again, let's highlight the important things you will be needing for your chapter 4. Okay. So if you have a 2,000 calorie intake per day and your mean score is 1,563.5 calories, it actually means that you're going lower than the regular calorie intake. So faculty members are not stressing out on eating, I think. Yes. And if, for example, the highest score for being for having high stress is 50 and you have a mean score of 36.6, it's a bit higher than the middle or the average. So I guess faculty members are also pretty stressed according to this data. Okay, so for computing your Pearson R, what you have to do is, again, go to data, click data analysis, press correlation, click OK, and then highlight both of your variables. They are grouped by column. We're using columns. Labels in the first row. Let's do your input range. Let's put it over here. Press OK. So you can see here that, of course, calorie intake has a positive relationship with calorie intake because it's the same thing. So what you're looking at here right now is the intercept between the stress levels and the calorie intake. So it's this 0.04. Let's highlight that. And then, so this is just your R value. This is not yet your P value. So how do we know if this is a significant relationship or not? So what we do there is we do it, it's kind of like a cheat. So go to go to data, click data analysis, look for regression, which is another inferential statistic for a later or another session on this, or a later session on quantitative analysis. Yes. So click regression, press OK. Input ranges doesn't really matter because we're not looking for regression anyway. Oops. See, I made a mistake. That's why you have to be mindful of clicking this output range space over here. Oof, what happened? Okay, I didn't press the label. Okay, what's important to look here is the significance F. This is your p-value. This is standard, so it will never change. Right. Okay, so let's fill in the blanks here. So your R value is 0.04, this one. So it's not too far from 0, but we will find out if it's significant or not. So your significant F or your P value is 0.88, which is obviously higher than 0.05. Again, golden rule. If your p-value is less than 0.05, you reject your null hypothesis. So for this case, since 0.88 is greater than 0.05, we accept our null hypothesis. So it means that there is no correlation between the calorie intake and stress levels of faculty members. Why is this? Could be because faculty members are more busy with other things to relieve their stress, or maybe eating is not their way of relieving stress. They're doing something. Maybe they're exercising, or maybe they're playing Candy Crush. It's all dependent on your RRL, on what you find out. Or, yeah. So congratulations. Now you know how to compute and interpret your Pearson R correlation. Okay. Don't forget to save. Let's go to single factor ANOVA. So when we use the single factor ANOVA, again, like we said earlier, it's just multiple means being compared. So for example, for this t-test is we have just two groups. For single factor ANOVA, we have three or more. Depends on your thesis. So our problem is a researcher wanted to investigate the most effective way to teach renal physiology to first-year medical students. So he divided the students into three groups with 20 students each. And so the groups are divided into traditional classroom, flipped classroom, and VR game. He then measured the knowledge of the students by giving a 50-point quiz after the module. So these are three uncorrelated, three independent groups. So they are not related to each other. One group has a different set of people from the next group and so on. That's why we will be using your single factor ANOVA because again, let us repeat it. They are not the same people. These three groups are not related to each other at all. So null hypothesis is that there is no significant difference among the knowledge scores of the three teaching techniques. The educational techniques. Okay. So again, first, we look for the descriptive statistics. So you have to get into the habit of this. Because it's actually healthy to practice this descriptive. I hope you're doing this with me. And I hope by this third example, you already got the hang of navigating in your software. Okay, important again, let's highlight your mean and standard deviation. We will be using that for your chapter 4. So after, so let's look at the descriptive statistics first. So you can see it here that the lecture technique actually has the highest mean among the group. So you have the highest score of 50 and those in the lecture got a mean score of 41.05. It's actually pretty good. Yeah. So how do we know if there is a significant difference among the three groups? So we go to data, go to data analysis. Let's choose ANOVA single factor. The first thing on the list. Press OK. Input range, you just highlight everything. It is grouped by columns. The labels are in the first row. Our alpha is 0.05. Our output range, let's put it here. And press OK. So this first table over here just shows you a bit of descriptive statistics, but again, we would like to prefer this one because it is more informative and you have everything that you will need. And here we have the sum of squares, the degrees of freedom. and the mean square for between groups and within groups. So again, what is important to look here is this p-value. Let's highlight that one. So if our f value is 0.98, that's your f, and our p-value is 0.38. So again, golden rule, if your p-value is less than 0.05, you reject your null hypothesis. For this case, our p-value is greater than our alpha 0.05, which means, again, we accept our null hypothesis. So there is no significant difference among the scores, but yeah, there's no significant difference. So let's say, for example, our p-value is less than 0.05 and we reject our null hypothesis. So what you will do then is you will do now individual t-tests to determine which of these pairs have the significant difference between them. So you have to do it one by one. So lecture versus flip, flip versus VR, lecture versus VR. Yes. But the thing I like about using single factor ANOVA is that you can already see in general if there is a difference or not. So now that we've seen that there is no significant difference, we can just move on and not look for the t-test anymore. So it's actually convenient. So again, now that we've computed for our single factor ANOVA, let's save that because that is important for our life. And let's move on to the last sample problem that we have for this lecture. So this is two-way ANOVA. So when you say two-way ANOVA, you have two independent variables and one dependent variable. So these two dependent variables have to be of nominal scale. So they have to be in categories. So either they can be gender, they can be year level, they can be socioeconomic status, they could be stress level. You can group them into low level stress, mid level stress, and high level stress. So whatever it is that is in your research, if that is a categorical variable, you can maybe use two-way ANOVA in your research. So, for example, here, our problem is a researcher wants to know the effect of teaching methods and academic year level in learning orthodontics. She measured the knowledge of third year and fourth year dentistry students after finishing an orthodontics module using traditional lecture and VR games. So you can see here that we have two categorical independent variables. So the first one is your year level. So for this specific example, we have third year and fourth year. Yes, third year and fourth year. And the second categorical variable is your teaching method. So either you have your lecture or your VR. So for two-way ANOVA, aside from looking at the significant difference between means, you are also looking at the effect or the interaction of those two variables to your independent variable. So for this specific example, will the academic year level and teaching method have an effect on the student's knowledge on orthodontics? So for two-way ANOVA, there are two kinds. So you have the, let's see here in your data. So here you have with replication and without replication. So when we say without replication, you are just, so for example, for this table, you are just looking at one, one pair per se. So for example, you are looking at these two. So if you're only looking at this, you will use two-way ANOVA without replication. So what is the difference between that and this one? So here, it's two separate groups. Two separate groups. People are different here. Again, people are different here. But with two-way ANOVA, you're just using the same group of people doing multiple tasks. Yes. So if it's the same group of people doing multiple tasks, you will use your two-way ANOVA without replication. But because we have two groups, here you have third year and you have your fourth year, we will be using two-way ANOVA with replication. In two-way ANOVA with replication, you are also testing three hypotheses. So the first hypothesis is that there is no significant difference between knowledge using lecture or VR. So that's the first one. So you're comparing column per column. The second hypothesis is there is no significant difference between the knowledge of third year and fourth year students. So you're comparing row per row. So row and column. So again, H1 is row, column, and the second one is per row. And your third hypothesis is to determine if there is an effect or an interaction between these two in affecting the scores. I hope this is clear so far. I know two-way ANOVA can be a bit confusing, but you can do it. I trust you. Okay. To compute for your two-way ANOVA, let's go to data analysis, of course. Two-way factor with replication. Input range, you just highlight everything. And rows per sample. So we have 10 students per sample. Yes, okay, we have 10 students per sample. Our alpha is 0.05 and our output range, let's put it here. We press OK. So again, we have summary statistics, the basic ones. Let's not do the descriptive one for this example, so we can move forward with the discussion since this is the last one. Okay. So we can see here, this is our ANOVA table. This is the most important thing for this statistical treatment. So this represents your H1, this is your H2, and this is your H3. So I'm sorry, this should be the other way around. So this is third year and fourth year, and your H2 should have been That should have been the case. So let's say it again. So H1 is your rows, H2 is your column, and H3 is the interaction. So again, the most important things are these values over here. So for H1, the p-value is 0.10, which is greater than the alpha 0.05. So we accept our null hypothesis, our first null hypothesis, and the p-value for H2 is 0.83, which is again higher than our alpha. So again, we accept it. And same as for our H3. Accept. So we can say that there is no significant difference between the third year and fourth year scores in terms of lecture and VR. There is no significant difference between the knowledge using VR and lecture. And then for H3, that there is no interaction or effect on the teaching method and academic year level in learning orthodontics. So again, you will have to look at your RRL on why this is the case, like possible explanations why there is no effect or teaching method and academic year level has no effect on learning orthodontics. So again, after that, we save our work, and that is it. You have just learned a semester course on statistics, specifically quantitative statistics. Stop share. Okay, so that is it for the lecture. I hope you guys found this helpful. You can go back to this video whenever you think you need help. And again, on your handout, everything is there. So all the steps are there for you in whatever statistical treatment you will be using. So much luck to all of you. I hope this has been very useful, and I hope you found the joy. Sorry, I hope you found the joy in doing statistics for research. That is it. Thank you, everyone. Have a nice day.